looking at section 222, which is titled, What is the Significance of the HK? Okay, so we're going to be describing the HK for each of the family of functions, and by the end of the period or lesson, you'll be able to identify the HK for graphs of parabolic, cubic, absolute value, exponential, and square root functions, and you will be completing a team task. In lesson 221, you learned that you could apply your knowledge of transforming quadratic functions to transform several other parent functions. In this lesson, you will consolidate your knowledge of each of the parent functions, and you will identify the importance of what they're now calling the locator point. You know it as the vertex, HK, for each of the parent functions and its families. So obviously, when it's in a quadratic, it's going to be a vertex. But on other parent graphs, the HK might be the center. It's going to be an important part of that parent graph, whatever it is, okay? In a minute, you guys are going to come back and do question 51 in your groups of 4. You're going to think about the parent function y equals x squared, which we've talked about a lot. Write the equation, shifted 4 units to the right. And do you think, or does this strategy you use translate parabolas horizontally also work for other parent graphs? Justify your answer. Okay, so you hopefully looked at some on Friday, and you should be able to answer that question. And then down at the bottom, what does it want you to do? It says you have learned that the graphing form of the parabola y equals a times x minus h squared plus k. To translate the graph y equals x squared, write h units, replace the x squared with x minus h squared. Work with your team to justify why replacing x with the x minus h translates a graph to the right. Think about multiple representations as you discuss this, and be prepared to share your ideas with the class. Okay, so it gives you a spot to make a table, and it gives you a spot to draw a graph if you want to justify it. Okay? All right, flip over to page 15. Up at the top is question number 52, and it says, in your team, brainstorm a list of all the families of functions that you have learned about so far. If you can't remember all of them, look back at question 25 that we did on Friday, and it'll be super helpful to you. But try and name as many as you can without looking at that list, okay? Some of you might, as a group, be able to come up with all of them. Okay, for question 54, it says, what is the parent function for the graph of a line? Use what you have learned about transforming parent graphs to write the graphing form of a line. So the parent function for a line is just y equals x. Most of you in your head, you're like, no, it's y equals mx plus b, right? That m would, in this case, would be a 1 or 1 over 1, and the b, in this case, would be 0, okay? But that is the parent function. So if you were going to translate it and or reflect it, you could have something here that reflects it or stretches it, makes it steeper. Okay, this is going to move it left or right. This is going to move it up or down. So part A says, using this graphing form of a line to write the equation of a line with the slope of 4/5 that passes through the point 3, 9. We're going to plug those numbers in to that equation that they just gave us. We know that the slope is our m, right? You guys all remember that? Yes, yes, yes. Okay. And any point given to us is in always the x, y. So we're going to use 3 for x and 9 for y. Plug in those 3 numbers. Plug in the 4/5 for m. Plug in the 3 for x. Plug in the 9 for y. So we're going to have y equals 4/5 times the x minus 3 plus 9. Okay? Part B is very similar, but they want us to write the equation of the line, but that passes through 2 points. So instead of giving us the slope, they give us 2 different points, which we could calculate the slope and then use the slope and one of the points. But instead, I used one of the points for the HK and one of the points for the X and Y. Plug them both in, and that gets us pretty much the same equation. Okay? So the first point I used for H and K, the second point I used for X and Y, plug them in and then simplify. Okay? So make sure you follow order of operations when you do that. So in the first set of parentheses, or in the set of parentheses, the 8 minus negative 1, minus a negative, becomes like adding a positive. So 8 plus 1 is where I got the 9 from. Subtract the 5 from both sides and then divide both sides by 9. That gives you an A of negative 7/9. And then you just plug in that negative 7/9 and then use the negative 1 and the 5 for the H and the K. This is plus because the standard equation has a minus, and this is negative. So minus a negative, that should be plus. The 5 plugs in there, and that's your equation. So in your group, you'll answer the learning log together as well. So what can the point H, K, often called the locator point, tell you about how to graph a function from its equation? That should be pretty easy. And how can the locator point help you write the equation for a function given its graph? Okay? So you're going to break up into your groups. You're going to answer question 51, 52, and then do the learning log together. Okay? If you guys get stuck or need help, let me know. I will be glad to walk around and answer questions if you need it.